Welcome to mathematics class. We shall be solving as many questions as possible in this section with Surds. So the first question, don't forget that we have discussed earlier in the previous teaching video about bá a ṣe lè solve question tó jẹ́ surd, and pé tó bá fẹ́ add surd méjì papọ̀, number one tó gbọ́dọ̀ ṣe ni pé èyí tó jẹ́ surd gbọ́dọ̀ ṣe kíni, ó gbọ́dọ̀ jọ surd àkọ́kọ́, gbọ́dọ̀ jọ surd ẹlẹ́ẹ̀kejì. Tí ó bá ti jọra wọn, ò lè ṣe kíni, ò lè add wọn. Gbọ́dọ̀ lè break it down, simplify it before you can do what. Tó bá dẹ̀ jọra wọn, you do what you add. You cannot add it, you leave it that way. And tó bá dẹ̀ multiply, you do what? You simplify, then you can now multiply surd with surd and whole number with whole number. You understand? So that's that about that. That's about. So let's solve this question as quickly as possible. So we have 2, 5 all brackets. Okay, so what do we do? This is ìtumọ̀ ilé jẹ́ pé nǹkan tó wà ní bracket yìí o ẹ̀ẹ̀mejì ló yọjú. So that means this times this lọ́nà méjì ló jẹ́, just like yẹn say a square, ìtumọ̀ ẹ̀ ni pé a times a ọ̀nà méjì ni. Do you understand now? So what do? We can say 2 root 5 times 2 root 5. Understand? Those are the two. And with that, we can do what? We can multiply. We can 2 times 2. Don't forget the multiplication rule that if you are multiplying two surds, you multiply the surd by surd and the whole number by whole number. So 2 times 2 will give us 4. And also will give us what? 5 times 5 will give us 25. And from there we can say 4 root 25 will give us 5. So 4 times 5. You understand? So 4 times 5 will give us what? 20. That's the final answer. Or you can say that 2 root 5 square can be this times what? 5 and this. Understand? So 2 times 2 will give us 4. This and this. So you are what? You are left with 5. Then you have 20. Still the same. Can you see? So it's easy to choose. Just follow the steps. And àkọ́kọ́ ni pé kọ́kọ́ wò pé báwo ló fẹ́ break kíní down. Tó bá ti mọ bó ṣe lè break it down to get the factors, then you can do what? You can easily do that. So let's go to question 2. This is 3. You understand? So multiply the 2, this and this. If you multiply the 2, what do you have? So you have your what? 18. But this can still give us what? This can still give us we can still simplify this. Why? It gives us what? It gives us a perfect square and a whole number. Abi 2 times 9 will give us what? 18. So that means you can say 2 times 9 will give us 18. Abi? So from there we break it down, we separate it. Root 2 times root 9, which will further give us what? 2 times what? 3 which will be 3 root what? 2. You can see that. So you have to, when you but I get a I will okay actually simplify again. Why? Because we can still get a perfect square, or we can still get factors that will be simplified further. That's why we look at it. But should in case we cannot get something that can be simplified further, let's say this is 2. Let's say we didn't have this thing, we have 2 here. So we have, that is 3 times 2. 3 times 2 will give us 6. We may not be able to break it down like that. So that's why we have that. So let's go to 3, question 3. So question 3 saying 6 over root 3. This is the division, right? Now this is division, right? Division in Surds. So division in Surds, the first thing you should first of all consider is this. First of all, consider that if a fraction has a surd in the denominator, if a fraction has a surd in its denominator, then what you need to do is to do what? Is to rationalize the denominator. You understand? You rationalize the denominator. To rationalize the denominator, it means that you want to make denominator into rational number. You understand? Rational number, a whole number, a whole number. So Tebati saw the whole number, then you now multiply that. You multiply the denominator by what? By that fraction. So that by the time you multiply, you make it a what? You make it a rational. Do you understand that? Okay, let's look into it. Let's look into it so that you're able to know how to resolve it. You're able to know how to resolve it like that. You're able to know how to resolve it like that. So you have what I mean is this over this. So you now multiply this denominator. This denominator, you multiply it by numerator and denominator. So this root 3 is now, you have your what? 3 over root 3. Although when you have not actually added anything, by the time you divide it by this, you still remain, this will give you 1 for this. But you have to do what? Able to multiply it this way so that you can rationalize it. So from there, what do you have? You have 6. You can say 6 times this, and you have what? 3 times root 3 times 3. Do you understand that now? So you have that, then you can now say 6 root 3 over what? This by this will give us what? Will give us 9, right? So you have 6 root 3 over what? This root of 9 will give us what? 9 will give us what? 3. You understand that now? You understand that? So from there, since this whole number and this whole number is still divisible, you can do what? You can divide. So you have your 3 here 1, 3 here 2. So you have 2 root 3. So let's move on to this. This then we have for this 3 root 5 plus 2 plus 3. This is multiplication. So multiplication of surds. Understand now? This is one term, this is another term. We want to multiply by this. How do you resolve this, especially with this kind of surd expression? How do you multiply this? The first thing you should do, what you should use algebraic expansion. Algebraic expansion. Using algebraic expansion, such like, okay, if you have something like you have A plus B, you understand? You now have AB, okay, C plus D. You understand that? So how do you expand this? You multiply this by this. That will be AC, A times C plus A times D. That is AD plus this term again. This times this, it will be what? BC plus now B times D will now BD. So that is how you expand algebraic expression. Do you understand now? So it is the same thing that we'll be using in resolving that. So we have, let's start from here. We have this 3. Have this 3 root 5 plus 2. Then we have root 5 plus 3. So what we need to do is to do what? This by this. It will be out times 5. You understand now? This by this again plus 3 root 5 times 3. It's now be this times this. Now be what? 2 times root 5. Understand? Then it's now be plus this times it, that will go 2 times 3. 2 times 3. So from there, what do we do? This times this will give us what? 25, Abby. This one also will give us this, and these are our number. So we have 9 root 5, Abby. Then we have this and this, that will be 2 root 5, Abby. Then we have 2 times, that will be 6. You understand? So you can still simplify this. This will give us what? Root 25 will give us what? 5, right? To give us 5, Abby, plus 9 root 5 plus 2, 5 plus 6. Now, don't forget, one of the rules in adding addition of surds is that the surds involved in the what? In the addition must be the same. If you want to add this and this now, that means this value here and value here must be the same. You got to 1b, but you got to 1b. And when you want to add them, you add the what? You'll be able to add their whole number. But this, you pick one of the two. And whole number one, but that means one. So we have this to be what? 15 plus what? This and this, we add it together. 9 plus 2 will give us what? 11, 5. So you have added the two together. Plus what? 6. Abby. So what we need to do is to do what? Add this and this. This will give us what? 21 plus 11 root 5, right? 21 plus. So with that, we've come to the end of this. So 21 plus 11, that's the list. Do you understand? You cannot add this and this together. Why? Because they are not the same. This is whole number. This is a what? Surd. So you cannot add it. Except, let's say for example, we now have example. Let's say we have 21 root 5 plus 11 root 5. You cannot add it because this and this are the same. Do you understand now? This and this are the same. You cannot add it together. So, but we don't have that. So if you want to add something like this, then you have 32 root 5. But that's not the case. So that is our simplified answer. So let's quickly go to the last question, which is subtraction of surd. So when you are subtracting, the same thing that is applicable to addition of surds is still applicable to addition of subtraction of surds. Understand? This and this are the same. So you can do what? You can subtract their what? You can subtract their whole number. But if they are not the same, if they are not the same, you cannot subtract their whole number. You cannot subtract their whole number. So with that, what do you do? What do? You do okay, 3 comes before this, so minus 7. So you pick one of these. Then you have 3 minus 7. You give us that is negative 4, 5. That's that. Let's say, for example, if we have 7 root 5 minus 3 root 5. Understand? This can be what? 7 minus 3 root 5. 5. So this could be 4. Understand? But this is after this, so this is the answer. I'm just using that to know that you don't just place it anyhow. If this is how it is being given, this is how you are to do what? To subtract. So that's that about that. That's that about that. So I still want us to take a question. So we still have another video coming, another class, another section coming that we actually still go further, go deep in resolving questions relating to surd, maybe in trigonometry or that is okay, more conjugate. We will not actually do all more of conjugate here, but we have actually do the rationalization, the rationalizing of surd, rationalizing of surd. What do you do here? You do what? The fraction here, the square root, denominator, you do what? You multiply the root or the surd in the denominator, you multiply with what? The numerator, and you multiply with what? This the same denominator. By the time you do that, then you are rationalizing, because this will give you what? By the time you multiply this and you multiply it, although this still remain 1, because we divide by this, you give 1, it's still happy, but you need to resolve it like this so that you can get a rationalized answer in a simplified way. So do enjoy. Please subscribe to this channel so that you can learn more and more mathematical expression in other languages: Yoruba, Hausa, English, and Igbo. Thank you. Bye.